Assalamualaikum. I'm Afizan bin Ahmad Puad.
My name is Muhammad Shazwan bin Muhammad Rosli and my metric number is 159647.
My name is Nur Aina binti Roslan and my registration number is 159648. And as for my part, I will represent for the C section.
My name is Norliana Nabila binti Talha and my registration number is 155969.
Hi, my name is Nazwa Talha binti Muhammad Hatta, registration number 155999. Hereinafter we're known as group member E. Today we are going to show our group apparatus, experimental setup, and how we obtain the value of deflection using different constant angle which is 0 degree, 45 degree, and 90 degree.
A cantilever beam is a stiff overhanging structural element that is supported at only one end. Its design in housing construction is used for protruded balconies. Cantilever features also can be seen in the development of parking canopies and even as roof extensions. Cantilever beams can also be deflected by different types of load, such as shear loads, wind loads, and earthquakes. Too deflected cantilever beam will cause it to fail.
For section A, we will use this apparatus as shown. First, chicken stock tube to be as the load model. Second, plastic ruler as a beam. Third, paper clip as a clamp. Fourth, thread used for transferring load. Fifth, a protector for 0 degree determination. Sixth, a pencil to move the thread. 7. A piece of A4 paper to sketch the angle.
For B section, these are the apparatus that I use. Knorr chicken cube stock as load, plastic ruler as beam, paper clipper as clamped, thread for transferring load, a protractor for 45 degree determination, a pencil, a screw, and A4 paper.
Here, this is my apparatus used in this experiment. I have wooden stand, 16 cm plastic ruler, a protector, 15 cm thread, 3 variation of load which is Knorr cube, 10 gram, 20 gram, and 30 gram, and a masking tape used to clamp the ruler to the wooden stand.
By using protractor, draw view of 0, 45, 90 degree angle on a piece of paper. Then, the paper is set to be the main background. After that, attach the ruler on a stable chair by using a paper clipper. Tie chicken cube stock by thread and fasten it to the ruler. The experimental setup for section B is done.
I will represent for the C section, which is I will use the load of 0.091 Newton applied to my constant angle, which is 90 degree. Here is my setup.
Okay, I will present for this section, which is I use 20 gram and applied to 0 degree. This is my experimental of setup.
Now, this is my experimental setup using 20 gram applied load with 45 degree angle direction to calculate the deflection.
For section A, I will measure the ruler deflection when 0.0981 Newton load is applied vertically downwards at 0 degree. Take 0.091 Newton load attached to the ruler and place it on the 0 degree section. Now, measure the distance from the initial replacement to deflected ruler, and recorded is known as the deflection. In this case, the deflection is 0 mm.
For this section, I will measure the deflection of the ruler when 0.0981 Newton load is applied onto the ruler vertically downwards at 45 degree. Take the 0.0981 Newton load attached to the ruler and place it to the 45 degree section. Now, measure the distance from the initial placement of the ruler to the deflected ruler. The distance measured and recorded is known as the deflection. In this case, the deflection is 16 millimeters.
Where I use the load of 0.0981 Newton or 10 gram of load that I tied to the end of the ruler, and I will place it down to the angle of 90 degree. Now, I will measure the distance from the initial placement of the ruler to the deflected ruler to get the deflection. Like this. From here to here. As a result, the distance that has been recorded can be determined the value of deflection when the load of 0.0981 Newton is applied to the 90 degree angle.
This is my experimental of setup, which is I use 20 gram of no cube that I have tied and the ruler, and I put it on 0 degree. So after this, we can see the deflection if they have a distance from initial ruler. This is the condition of deflection, that no distance happen when applied 20 gram at 0 degree.
Gram of load, which is Nor cube, 2 Nor cube, which weighted 20 gram, and my applied load is 45 degree over here. Then I tie the load 20 gram to the using 15 centimeter thread to the point load as shown here. My load, which is 20 gram, is tied to the ruler using 15 centimeter thread. So now for the sample 20 gram with 45 degree applied load, we can determine the deflection using another ruler which is from here to here. Lastly, for the conclusion, the objective of this experiment, which is to determine the deflection of unsymmetrical loaded cantilever beam at different angles, is achieved. From the result, it is proven that as load is increased from 0.0981 Newton to 0.2943 Newton, the deflection also increased. There is insignificantly difference in the experimental value gained for every members, and difference binary value of theoretical and experimental is due to the assumption of E, which is modulus of elasticity. Inclined loads give different deflection value because of its effect in terms of Ixx and Iyy, and need to be resolved in terms of y-axis. Thus, although Ixx is present, however, it cannot be determined in the experimental procedure due to the beam is tightly fixed. Last but not least, Deflection of cantilever beam is important to understand since it describes the possibility of structural failure and conditions. It is best to refer building codes BS 811 or Eurocode 2 SCI code to know the maximum allowable deflection of elements. That's all. Thank you.